All right, Longhorns, this is the review for test 2 on Thursday. Make sure that you study for this test and that you know how to work all of the problems. Please watch this video and make sure that you understand everything you need to know. All right, first of all, we're going to take a look at how to tell if something is a function or not. First, we're going to look at a couple of ways that you can tell by using input-output. So if I have a function in table form and I want to see if this is a function or not, I want to make sure that for every value of x, I only have one value for y. All right, so in my table, I have all of these different x values, -2, -1, 0, 1, 2. And because each one of these x values is a different number, I only have one y output for each one of them. Even though the y output is the same for several of these numbers, that's okay. They can have the same number for the y output, but they can't have more than one y output. For example, in this mapping that I've made, I have an x input of 1 that has two y outputs. This one has an output of 4 and an output of 5. If your x value has more than one y output, then it is not a function. So this one is an example of something that is not a function, and this is an example of something that is a function. All right, solving for y. If y can be solved exclusively for y, then the equation that we have is a function. If y cannot be solved exclusively, in other words, if you have two different outputs, then your y value is not unique. The y the y is not unique. In other words, for that one value of x, I can get two different y outputs. Okay, so in my two examples, in this example, I'm able to exclusively solve for y. In other words, there's a unique y here no matter what value I put in for x. So whatever value I put in for x, I'm going to get only one y. For this y, however, I could put the same value in for x, but I'm going to get something that's positive and something that's negative. So I'm not uniquely solving for y here because y can have two different values for that one value of x. So anytime you see something with a y squared, this is not a function. This one is. Okay, in problem 2, we're going to determine the average rate of change for this function over an interval between 1 and 4. So what that means is that we're going to try to find the slope. And if you remember the slope formula, it's y2 minus y1 over x2 minus x1. And so we're going to need to use this formula. Now they've given us an x2 and an x1, but we don't have the y2 and the y1. So what we're going to do is we're going to take the x values they gave us, and we're going to plug those in to find y. So we plug them into the function. So for the first one, let's go ahead and plug in to our x squared plus 4x minus 5. We're going to plug in a 1. And when we do that, we get 1 squared is 1, plus 4, which is 5. 5 minus 5 is 0. So for the first one, I get 0. For the next one, I'm going to plug in the 4. And what I get here is I get 4 times 4 minus 5. I get 4 squared plus 4 times 4 minus 5. That's 16 plus 16 minus 5 is 27. Now I'm ready to do my slope formula because I have my y values now that I need, and I have my 2x values they gave me. So I'm going to start with the y's, 27 minus 0 over 4 minus 1. So what I end up with is 27 over 3, which equals 9. So my average rate of change is 9. All right, so in question 3, we're going to use this graph of the function f to answer the questions. And the first question is, over what interval is the function increasing, decreasing, and constant? So first of all, I want to look at this graph from the left. As I'm approaching this graph from the left, what is happening to the y values? As my x gets larger, what happens to y? Well, at this point right here, I'm coming in from negative infinity. As I'm going in, heading to the right, I notice that my y values are going up until I get to about right here. All right, that's right around -2. So we would say that the function is increasing from negative infinity to -2. Then, as we come down on the other side, between the x values of -2 and 0, between those values, our graph is decreasing. So we say between -2 and 0, the graph is decreasing. Then we look at the graph, we keep looking at the graph from left to right. Again, it starts to go up. So between 0 and 1, the graph is increasing again. 0 to 1, the graph is increasing. And then the very last part right here, from 1 to positive infinity, the graph again is decreasing. So we would say from 1 to infinity. All right? So we don't know if these endpoints are opened or closed. So we're going to not write these intervals as closed intervals. We're going to write them as open intervals for now. Later on, when you get to calculus, you'll learn how to determine whether those intervals are going to be opened or closed. We don't have any constant values either. We don't know whether any of these points are constants or not. So that's how we determine the interval for increasing and decreasing, and that's how we write it with parentheses. All right, so the next question is about absolute, maximum, and minimum. Well, our graph does have an absolute maximum. As we're looking at the graph, we see that the highest point on our graph is right here. That value for y is 8. So we want to look at the y value. What is the y value at the maximum? So the maximum value for y is 8. So the absolute maximum is 8. Now, since our graph is going down to negative infinity on the left and down to, or actually down to negative infinity on both ends with the y values, since we're looking at the y values for absolute maximum and minimum, the absolute minimum in this case is going to be none because we're going to negative infinity. So since y is going to negative infinity on both ends, then our absolute minimum does not exist. So we say none. So our absolute minimum is none. All right, so in question 4, we have 3 different things that we're going to do. The first thing is we're going to find f of 4. Basically what this means is that our input for x is 4. What we want to find is what is the output. So we go to the graph and we look over here to where x is 4. And we count 1, 2, 3, 4. And our graph lands right here when x is 4. So I'm going to put a little dot right there. Okay? So the y value when x is 4 is -1. All right, so the next thing we're going to do is state the domain and range. The domain for this function, if we count back to the first dot we see on the left, 1, 2, 3, 4, 5, 6, 7, this value for x is -7. And if we keep count to the right to where the graph ends at this dot, 1, 2, 3, 4, 5, 6, +7. So our domain for this graph, since it ends right here, is -7 to +7. Now the range is going to be read from bottom to top, not top to bottom. Range is read from bottom to top. You want to go low to high, just like we did for domain. We went low to high. We do the same thing for range. So I'm going to find the lowest point on my graph, and the lowest point on my graph is right here. So the value for y right there is 1, 2, 3, 4, -5. So the lowest point for y is -5. The highest is 1, 2, 3, 4, +5. So my range is going to be from -5 to +5. So you'll notice that when I wrote my domain and range, I wrote them in brackets. And the reason why I wrote them in brackets is because these endpoints right here are closed points. So because they're closed points, I'm using brackets there. All right, so the next question is asking, what is the value of x when f of x equals -4? This is basically means, what is the value for x when y is -4? So we look to our graph to see what the value for x is when y is -4. So the green line that I've drawn is all the values when y is -4. So we have a couple places on the graph where that happens, where the graph crosses this y equals -4 spot. Right here and right here. So we could say that for when y is -4, we have a value for x of, let's count, 1, 2, 3, 4, 5, -6, and 1, 2, 3, 4, 5. So I have two x values. So the value of x for y is -4 would be -6 or 5. In the next question, we are identifying the transformations of the following function. So again, I want you to read the equation from left to right. We're going to start with the first transformation. The first transformation we see is this negative sign. So this is called a vertical reflection. The next transformation we see is the 3. The 3 is a vertical stretch. Okay, any transformation that we see between the parentheses or inside the house, as we would call it, those are going to be horizontal transformations. So anything that happens to x is going to be a horizontal transformation. Okay, so this is a horizontal shift left 5 units. That's because this is actually x minus a -5. And because it's x minus a -5, we write it as x plus 5, but that is why we are moving to the left. horizontal shift left 5 units. Now for the last transformation, we have -7. This is going to be a vertical shift down 7 units. All right, let's review one more time. Okay, so the first thing we see, this negative sign here, is a vertical reflection. The next thing we see, this 3, is a vertical stretch by 3. The next transformation we see inside the house is a horizontal shift left, even though this says a plus sign, remember this is actually minus a negative, left 5 units. Horizontal shift left 5 units. And the last one, this one right here, is a vertical shift down 7 units. So remember, anything that happens outside the house, these transformations here are called vertical transformations. And anything inside the house is a horizontal transformation. In the next problem, we have evaluate a floor function of 5.8. So remember, this is a step function, and because we have these little brackets down here at the bottom of this function, this is going to be a floor function. What that means is that I've got a step function, and I'm not going to have any decimals as my solutions. I'm either going to have a whole number lower than this decimal or higher than this decimal. Now this particular number is 5.8, and if it's a floor function, then I'm going to round down. So I'm going to round down to 5. Now if that was a ceiling function, say the bracket looks like this, then I would round up. If it was a ceiling function, then the answer is 6. So be very careful when you're reading this question on the test. If you can't tell if it's a floor or a ceiling function, look very, very closely at the bottom. If it dents in, it's a floor function. If it dents in at the top, it's a ceiling function. So floor functions round down, ceiling functions round up. Okay, in the next problem, it says given the following functions. It gives you 3 functions, f, g, and h. So in part A, it says find f minus h, given 3. So if my input is 3, then I'm going to find out what the value of f is, and I'm going to find the value of h, and I'm going to subtract. All right, so I have plugged in a 3 into f, and I've plugged in a 3 into h. I'm going to find the values of both of those, and then I'm going to subtract those values. So what you need to watch out for on the test is you need to look to see what this is telling you to do, what functions to use, and which operation. It also tells you what value to plug in for x. All right, so I've plugged in my 3 here, and I get 6 minus 3, which is 3. And here I get 6 minus 3 again, which is also 3. And 3 minus 3 equals 0. So my value for this answer of f minus h of 3 equals 0. In part B, we're going to do a function composition. So what it's asking us to do now is it's asking us to compose a function f of g of x. So what I'm going to do here is I'm going to plug g of x into f and simplify. All right, so my f function is f of something equals 2 times something minus 3. And the something we're going to plug in is this g of x. And g of x is x plus 8. So I'm going to plug in x plus 8 into here and simplify. All right, so I've plugged in my g, which is x plus 8. I've plugged this in right here into my f. And now what I'm going to do is simplify this. Now, I need to distribute this 2. This is a positive 2, which makes my life a little bit easier. But I have to remember to distribute all the way through the parentheses. So it's 2 times x and 2 times 8. So I get 2x plus 16 minus 3. Then the last step I need to do is just combine like terms, which is be these numbers right here, 16 minus 3. So my final solution is 2x plus 13. So f of g of x is 2x plus 13. Okay, so in the next example, we're going to factor. And we're actually going to do a couple of different ones because this one really isn't, I don't think it's sufficient enough as a review question. So I'm going to add 3 more, or I'm going to add 2 more. We're going to do 3 total for the review. And I think that that will be enough to help you prepare for this test. So if you look at all of the terms in this polynomial, this is a quadratic. When I look at each term, I see that each term has a common value in it that I can factor out right away. Right away, I can factor out a 2. So I'm going to go ahead and factor out a 2. And when I factor out the 2, factor just means to divide. When I factor out the 2, my result is 2 times n squared plus 3n minus 54. So basically, I've just divided everything by 2. The next thing I need to do is I need to finish factoring this. It's not completely factored yet. I can factor this again. I can factor this into 2 binomials. So here I need to find 2 numbers that multiply to give me 54 that add to get me 3. So I'm going to use the numbers 9 and 6 because I know 9 times 6 will give me 54, and I know that 9 minus 6 will give me 3. So those are the numbers I'm going to use as my factors. So now I have this quadratic completely factored. I'm going to give you another example. The next example we're going to do is 2n squared plus 19n plus 35. Now in this case, I don't have a common number that I can factor out of each one of these terms. So what I have to do is I have to either do factor by grouping or using the box method. Okay, so whether I use the box method or grouping, both of the methods are very similar. I'm going to get the same result. So in the box method, what we do is we put the first term in the first box and the last term in the last box. Then we multiply the first coefficient by the last number, the last constant, and we get 70. Now we find the factor pairs of 70. Whether you're using the box method or by grouping, you still have to do this step. You have to find the factor pairs that multiply to give you 70. That add to give you 19. So as I was going through my list, I came down, I finally got to 5. 5 times 14 gives me 70. And I know that 5 plus 14 is going to give me 19. So I'm going to use this factor pair. All right, so I put my 5n and my 14n in the box. I know that these two are going to add up to give me 19. I have my 35 here, and I have my 2n squared here. Now I'm going to factor out of the boxes. I'm going to factor out through this column. I'm going to factor out through this column. I'm going to factor out through this row, and I'm going to factor out through this row. And what I'm going to end up with are the 2 binomials that multiply together to give me this. So when I factor out this column right here, I get this and this. These two terms right here have a 2 in common and an n in common. So I can factor out the 2 and an n. Now out of this column here, I have a 5 in common. only, just the 5. So I can factor out a 5. Okay, in this row, I have only an n in common between these two. So I factor out the n. The last factor I'm going to do is this bottom row right here. And the number that these two numbers have in common that I can factor out is a 7. So I'm going to factor out the 7. Now, since I don't have any negative numbers here, I don't have to worry about if anything's positive or negative. Everything is positive. So my two binomials are both going to be positive. All right, so I get 2n plus 5, n plus 7. You can also do this same thing by grouping. All right, so out of this group here, I can factor out an n, and I'm left with 2n plus 5. And out of this group here, I can factor out a 7, and I'm left with 2n plus 5. Now I factor out my 2n plus 5, and that leaves me with n plus 7. So whether you use the box method or the grouping method, both of those methods work fine. I don't care what method you use whatever method is easy for you. Let's do one more example. Okay, in this example, I'm just going to use the box method. That's my favorite. That's the one I like, but if you don't like it, that's okay. You can use grouping, but I'm going to use the box method. I'm going to put my first term in my first box, my last term in my last box. Now I have to multiply 3 times 56, and I have to find all the factor pairs that will go into that number. Okay, so I found my factor pairs that multiply together to give me 168, that add to give me a negative 31. So I know that my 7x needs to be negative and my 24x they both need to be negative. In order for me to get a negative 31, I need to be able to add those together to get a negative 31. So the first thing I'm going to do is factor out my first row. I'm sorry, my first column. So my first column is of 3x we'll be able to factor out. The next column, I'm going to be able to factor out a negative 7. And this first row, 3x squared and the negative 7x, I could factor out an x. And in the last row, I can factor out an 8. So I'm going to factor out a negative 8. So my two binomials are going to be 3x minus 7, x minus 8. And that's it. I want to wish you lots of luck on your test. Also, just a reminder that you do not have to turn in this review. This is review just for you to prepare for the test. So don't mail it to me, don't email it to me, don't upload it or anything. I am going to put it on Canvas, but as an ungraded assignment, and I will also post it to Edmodo.